Hey, what's up guys, my name is Cherno. Welcome back to the Game Engine series. So, first and foremost, if you haven't watched the video detailing what we are doing with the rest of this series, please watch it. I'll have it linked up there. It's called Let's Talk. It is pretty long. At least watch the first 11 minutes or so up until we get up to the planning thing, because it's just going to give a little bit of insight as to where we're going. If you are interested in the goals of this series and you're not just watching these videos one-off, then that is definitely my wholehearted recommendation to you. But also the rest of that video, even though it is long, is planning literally everything that we're going to be doing. Like literally just everything. The rest of the series has basically been planned already, and effective immediately, like as of today, we are following that plan. And so what's going to happen is I will be live streaming every single Thursday, at least in Australian time, starting from around 11 a.m. Australian Eastern Standard Time. I will be live streaming myself actually working on this stuff. I might open up some stuff and show you guys in a minute. But I will be live streaming myself kind of developing Hazel 2D, which is this new project. We've kind of renamed it from the Game Engine series version of Hazel to Hazel 2D. I did a stream earlier today in which I did that, and that's going to be happening every Thursday. If you are interested in more details, then just watch the stream. The Twitch VODs will stay up for about 60 days. And you can also check the schedule, which actually let's just bounce into it. Let's just bounce into it. So we have a schedule. I'll have these links below. If you go to my Twitch page and then you click on schedule, you'll see when the next stream is, and you can see that I've working on Hazel 2D. Like I've got that locked in every Thursday around this time. So if you want to see when that is in your time zone, check it out there. Otherwise, the streams will remain up here. You can see this one was like 4 hours ago. This is basically what I just did today, right? So that's gonna be the new structure. We're gonna be planning this stuff during live streams, working on stuff actively during live streams, and then everything from these live streams goes into a branch called Dev. So there's this new branch in the official kind of Hazel public GitHub repository, which that's also linked in every episode, so it'll be in the description below. We have this dev branch, right? And this dev branch is what I did today, and that's what we're going to be talking about. So because a lot of people want to actually still see this series as a live coding, live programming series, I will still write all the code out, and it might even be slightly different to the way that I did it in the live stream. But I use these live streams to just test stuff out, and that way I can produce these condensed episodes, which is what you're going to be seeing today. But I will still discuss everything. I just know the code that has been written. And actually, you could even say that I know it twofold, because step one is writing it usually for Hazel, like for real Hazel, the Patreon version of Hazel that's 3D and everything. That's like the big kind of proper engine that I'm working on. So that obviously already has, a lot of the stuff that was detailed out in the roadmap. So that's kind of like step one. I've done it there, but then I do it on live stream in Hazel 2D's context, and then I jam it in, right? So I don't mind doing that because it lets me think about how I'm going to teach it, and it's just preparation for teaching it. But also there'll be a lot of cases in which I will simplify the design or change the design, because when I did it the first time, I mean, you guys probably know, if you've been programming for a while or you're software engineers, you know that like when you solve a problem the first time, if you were to solve it again, you'd probably do it slightly differently. And so I kind of like that. I think it's a good idea to do that and to do it on stream, so that if you really want every drop of content, you can get that. And then finally, after the 60 days, when Twitch will delete that VOD, the VOD will go up onto like an unlisted YouTube channel for patrons. So that way you can access the entire backlog of pretty much every live stream I've ever done, which I think is pretty cool. So that is kind of like a little bit of like planning, like where we're at and what we're gonna do. Now the second thing I wanted to quickly show before we get into this, I know there's a lot of like meta stuff going on here, but we have this roadmap, and this is what I also spent doing like in the live stream, and I talked about these things in more detail there. Again, it's kind of similar to the planning video that I did. It's called Let's Talk, but this actually has a progression. So that planning video, everything was out of order. It was just, here's a bunch of stuff that we need. I don't know what the order of progression is. This, if you read the README, you can see it contains a feature roadmap, and read this board from left to right. That's the order of progression, right? So a few things will kind of overlap here and there, but you can see that we basically, we're going to be basically starting off with physics. which is actually not what we're doing today, but we're basically going to be starting off with physics and then moving on to scripting and then doing analysis. Anyway, you guys can read all of this. There's a bunch of stuff here. It's going to keep getting filled out as time goes on, but that is basically where we are at. Now, the first thing that I want to do, and I'm going to start doing this during live streams, but I want to kind of look at the issues and the pull requests that we have. Now, this stuff, I'll look at all of these in the next live stream, right? I'm not going to waste time doing that stuff now, but what I do want is this, I believe it's this one. I want to make sure that I get the first one, because when did I release that? I think it is this one. Because this is, I believe, the fix for the rendering bug that we had in the previous episode, right? So the previous episode, which I'll have linked up there, by the way, not the kind of talking one, but the actual, yeah, I need to fix that GUI layout. The actual kind of previous episode, I was just playing with the GUI layout at some point. Don't even know why it's like this. So the previous episode in which we actually did real development, we had an issue, I think, where if we applied a texture to this, so we now have the ability through the content browser to actually drag in textures like the Cherno logo, it just looked weird. And it looks like for certain pixels, it decides to use no texture, which is why you see pink. For other pixels, as it rasterizes this, it chooses to display the texture and you get this weird thing. And someone has fixed it. So this is the pull request. So what I want to do is, I can see the changes here. This is a really quick one, so I'll just accept the pull request. But you can see that if we kind of go through this fix and maybe do a bit of a code review, moving text index out of the struct, because you can't have flat variables, unfortunately, in a struct. They all kind of get interpolated. So what the flat keyword does in GLSL is it basically means that when you go from the vertex shader to the fragment shader, we don't want any interpolation, right? Usually, I don't know how much. Let me know what you think about this depth. I guess this is the Game Engine series and it's an educational series, not a let's watch Cherno write code for an hour without saying anything serious. So because of that, I will explain like a little bit of this stuff. But basically, we have a vertex shader. Let's make that fat, please. We have a vertex shader, we have a fragment shader, right? So the way that this effectively works is that we have, is this lagging? What on earth, man? Why is it lagging? Unbelievable. I have like I've got 16 cores, 32 threads in this machine, and it can't handle a couple things at once. Whatever. So maybe paint's just, anyway, whatever. Let's just move on. So we have a triangle, right? And we have certain data at the vertex positions of this triangle, right? So in this case, you can see that we have, for example, a text index. So if we have that text index here, we have like, I'll just label it I. So we have a text index of like, maybe text index isn't the best example here, but let's just say we have a color, and the color has a value of 1 here, a value of 2 here, and a value of 3 here. Well, the thing is, the vertex shader runs on vertices. So we have 3 vertices here, 1, 2, 3 vertices. So it's pretty clear what the values are. But when you get into a fragment shader, you have the same triangle, but obviously the fragment shader runs for every pixel that's visible. So if it's running for every pixel that's visible, then like what happens if we try and move this data, not move it, but access the data from the vertex shader and the fragment shader, like we do when we use a varying, as they used to be called, or here like an output variable, right? So what happens is it interpolates the values. So in other words, if I pick a pixel that is halfway between these 2 vertices, I'm going to, because it's linear interpolation, get the value 1.5 because it's halfway between 1 and 2, right? If I'm here, I'm going to basically linearly interpolate between 3 values and get that result, right? That's a really good example as to why smooth normals work. We might have a sphere that is technically like some kind of octahedron, maybe not that low, like kind of fidelity and low amount of triangles, but you get the point that our sphere is never going to be perfectly round, I guess. It's still made up of triangles. However, it looks very smooth when we light it. If we look at it lit, the kind of fall off of the color is so smooth you can't tell that it's flat shaded. And that's because these normals are smooth, right? As long as you export your mesh with smooth shading, right? They will be smooth, and per pixel, they will be interpolated. And that's how you get smooth shading. So the idea is we have this concept of interpolation. And since we have this concept of interpolation, we want to be able to turn it off sometimes. And a good example is if we know that we have a flat float text index. To be 100% honest, I don't know why it's a float because we cast it to an int anyway, and we use an int here anyway, so it's not like we're avoiding integers. That might need a bit of a revisit, but the point is flat, we don't want interpolation on it. And it's been removed from this struct because you can't mark this float as flat if it's inside a struct. Just can't be done. I don't know why. That's just the way it is. It might be to do with how it actually sends that data over or something. But there we go. So in flat float again, and then we switch from using input.textIndex from within the struct to using just vTextIndex. So this is a great pull request. All the code is in the correct style. You know, you've got the v underscore, the naming's correct. So I'm going to squash and merge this. I'm going to rename it though to fixed text index being interpolated in shaders. In what's the shader called? In texture shader. Okay, so that's it. Boom. Not going to spend too much time on this. So how do we then do that? So, well, I mean, what does that effectively do with the pull request? It just means that pull request, I think this is in the content browser branch, right? Yeah, so that pull request has now been properly accepted. You can see that the latest commit is in fact by stantool007. So that means that if I were to find, I've got so much stuff going on in fork, you don't even want to see it. Including some secret stuff that I can't show. But what I'm going to do now is just basically pull. I'm going to pull my own code, even though it used to be up to date, but now obviously we have a pull request merged in. So that is the plan. Okay, so I have indeed pulled the code. You can see that change over here. Now, one thing that is worth mentioning, definitely because people forget this all the time, is that currently because we don't have any kind of like we don't have like a hash system for our shader. We don't know if the shader has changed, so we have to manually delete the shader from the cache. So usually I just clear the cache by just deleting the folder. You can just delete this entire cache folder if you want, and then it will regenerate the shader binary, which is important. Otherwise, we'll still be using the old shader. So don't forget to do that. In Hazel, in real Hazel, we just basically hash the string, the entire shader string source code, using a hash function into like a 32-bit, I think it is, hash, and then we store that in like a database. It's not really a database, like a YAML file. And then that way we can basically read the shader source code, compare it to the string, read the shader source code, hash it, compare it to the hash that's being stored in the database, and then if they don't match, we know the shader source code has changed and we need to recompile the shader. So that's how we deal with it. It's pretty common. Because that way, again, we don't need to manually delete anything. If you just modify shader code, it will recompile just that shader next time you launch Hazel. Obviously, you can also reload shaders by manually clicking reload next to them in the editor. But yeah. Okay, so if we try that again, I haven't tested this, by the way, but I'm assuming that is in fact the solution and that person doing the pull request has fixed it. So if we look at textures, Cherno logo. Okay, there you go. You can see it's completely fixed. Now the Cherno logo might look weird in terms of colors. That's because we multiply these two values together, remember? So texture and color gets multiplied together. So if we just set the color to be white, then you can see that now we have no problem. And we even have transparency working properly. That's a complete fluke. If we make them all Cherno logos, I think we'll start to see problems because... All right, wrong one. So you can see, like in this case, I can't see that texture is being cut off. So the reason this is happening is because, first of all, we don't have any kind of order-independent transparency. Instead, we're rendering these in a particular order, and I'm not even sure what the order is. This one looks like this one is being rendered first. Because it's being rendered first, there's no data in the frame buffer for it to blend with anything, and so we get just the clear color. Even though there's stuff behind it. It's because this is being rendered first and that stuff's being rendered later. So what we would want to do is either use like a order independent transparency kind of algorithm and setup, or we would want to sort from back to front when it comes to transparent materials, right? But again, this is more of a 3D thing. Don't know if you necessarily need this for 2D because you could just render Well, what could you do? I mean, you could just have a back to front rendering set up for 2D anyway and disable depth testing. But anyway, we're not going to get into this stuff. This is, I'm getting a little bit distracted, but I hope that this kind of general conversation is kind of beneficial to you guys who are still watching this series, because you want like just a little bit more of a game engine kind of environment rather than a step-by-step tutorial series. That's what I'm really hoping for. But anyway, let's get on with our task for today officially, which is... and again, I'm going to be referring to the code that I wrote earlier in the live stream. So if you want to see, if you really want to truly live format Cherno figuring out this code for the first time ever, then check out the live stream. Although joke's on you, because in that live stream, I was kind of stealing code from Big Hazel. So yeah, lol. But anyway, so what are we doing today? Let's get to it. So today we are going to be creating a play button. Why? Because first of all, we already have the ability to kind of run our scene as a runtime, kind of. It's like half done, right? If you actually look at the scene, let's take a look at this, scene.h, right? Then you can see that inside scene.h, we have onUpdate runtime and onUpdate editor. We have these two functions, right? They do slightly different things. The biggest difference between them, apart from like other script stuff, the biggest rendering difference between them is that here we actually use the camera from the camera component on an entity in our scene, whereas here we pass in an editor camera, right? The reason why this is important is because the first thing that we want to do is physics, right? We want to integrate Box 2D, and then we want to start adding physics components, and then of course we need to simulate our physics. And how are we going to do that at the moment? We don't have a play button to hit play, or we don't have a simulate button to hit simulate. I also showed how like proper Hazel works in that regard, and I even set up a 2D scene for proper Hazel, so definitely check out that live stream if you want to see that. But other than that, it doesn't really matter too much. I'm not going to show it here, but the point is that to do this, like, I just decided it'd be slightly better if we were to just you know, kind of, even though we have a play button here, and also I think in runtime we have play button in editor as well, we've got it in a few places. It's probably better to do it now, because that way we have something to actually simulate, and we can easily do that using the UI. And also it's not going to take long. So that's what we're going to do this week, and then next week we're going to jump back into you know, integrating Box 2D, adding physics components to our entity component system, and all of that good stuff. So let's dive into this. So the first thing we need is some resources. Now, I actually have two icons, which I prepared earlier, and these are directly from Hazel. So let's see, Hazelnut resources. And then what I want to do is into icons, content browser. I guess this is all for the editor anyway, but so I'll just do play button, stop button, right? These are two icons. There's really nothing special about them. They are literally just this, and then the other stop one you can imagine is even better. It's just this, right? So very simple icon. If anything, I think they're slightly low resolution. I'd almost like to increase the resolution on them. 32 by 32 is quite small, because they will be, so I might change them later, because you might want to make the toolbar bigger. But the first thing we need to do is actually create a toolbar. So my vision for this is kind of what it is in Hazel, in proper Hazel, which is like there's a toolbar basically up here that has like a play button. So what we're going to do is make a play button that turns into a stop button when we actually, you know, are playing a scene. And then if I click it, I want to be able to play a scene. So let's do that. So let's head on over into editor layer, and we're going to start designing this. So this is going to be an IMGUI panel, basically like an IMGUI window. Everything's an IMGUI window. So let's go ahead and make a function, because I want to organize this nicely. We'll have some like UI panels, and I want to call it UI underscore toolbar, right? So basically anything that starts with UI is specifically a UI panel. The reason why I want to do this is because currently, and let's move this close to like on IMGUI render. We'll put it probably right under IMGUI render. This is getting very cluttered, right? I mean, if you look at this, there's a stats window. Like, it's just nice to have these in separate functions, so that if you're looking for like, oh, I don't know, I want the toolbar, you can just easily jump to it. It's a separate function. Everything's nice and clean. And we'll call this before we end the doc space like that. It doesn't matter too much. You can still dock it even if it's not inside the doc space, but I'll do it this way. So UI toolbar, and then I'm going to basically start copying some code that I wrote during the live stream. So we're going to begin we're going to begin this window. We're going to call it, it doesn't really matter. Like, I don't think we have to use this double hash. So if you guys don't know, if you write, you know, just text here, it will appear as your window title. But anything that is after the double hash here, that just contributes to the identifier, like the ID of the window, which is important for like input events and various other things like docking, but it will not appear there like as a text for the window like this, like a title. But we're not going to see the title bar because we're going to make this without decoration anyway. So I don't think it matters terribly if it says toolbar here or if it's after the hash, because we won't see the title anyway, but whatever. We're going to set open to null pointer. This just basically means that there's no close button because we don't want to be able to close the toolbar. In fact, since it is going to have no decoration, which is the next thing that we're adding, window flags, no decoration. Since it is going to have no decoration, then again, we're not going to have a close button. I'm GUI window flags. We've got two more. No scroll bar, and then also no scroll with mouse. We don't want to be able to scroll this stuff in case it gets too small. We might want to set a minimum size later, but that's basically our I'm GUI window. That's our toolbar, and that's what's going to hold that button, right? And then we'll dock it up. You'll see in a minute. It's much easier when it's actually visualizable. So the kind of main point of here is to have an image button, which is going to be our texture, which we haven't loaded yet. And then if that's clicked, we want to basically do on scene play, but that depends on the current state because this button's going to change into a stop button later. So if the scene, if M scene state, which we haven't made yet, is scene state play, right? Or rather, well, it doesn't really matter what order we do this in. Let's just do edit. If it's edit, then we do on scene play. Otherwise, if it's play, we're going to do on scene stop, right? Because it's going to be a stop button. Now, there are other scene states. So Hazel has two others. Hazel also, so there's edit, play, there's also pause, and then there's simulate. So simulate will run your physics simulations without actually starting the game. So that's useful if you're like editing and stuff, because you can still use the editor camera to fly around, and it's nice to have that. Unreal Engine has a very similar thing. So that's what those are. So that's why I'm kind of writing this not like a else, because what else could it be? Because there are potentially other things. So let's make an enum class called scene state, and this will basically be edit and then play, right? I'll explicitly kind of label these just in case we serialize them or do other things to them. And then let's say scene state M scene state, and then we'll set that to scene state edit to begin with. Okay, so on scene play, on scene stop, let's make those functions. So on scene play, on scene stop. So these are actually quite simple because all we have to do really for these is set scene state to play and then set scene state to stop, right? I mean, in the future, we will probably want to do other stuff to it. I'm just wondering where to put this. Maybe let's do it like before on update. That's a layer thing though. I like to keep the layer things organized. Maybe we'll do it. I guess we will do it here. Put that back. On scene play, on scene stop. That's kind of pretty much like the only things I think we want to actually do for now. So stop, edit is what I meant. Okay, so this is pretty good. Let's try and load those images now. So when we do on attach, you can see we load some kind of texture here. We're basically going to duplicate this stuff, make this, I'll call it icon play and icon stop. And then this is just going to be like what? Resources. See if I can remember this off the top of my head. Resources, icons, and then like play icon, maybe. Is that where we're at? Button. Whatever. Okay, so icon play, icon stop. Let's do like editor resources, ref texture 2D, icon play, icon stop. I guess we can kind of pair them like this because they're relevant to each other. Scene state's kind of an important thing. I think I might want to put it up here. Okay, so play and stop, and then again, with the actual icon that we put into the image button, that's going to depend on what state we're in, right? So icon equals, what we'll do is basically check to see if it's edit. If it's edit, well, then we'll make it play, otherwise we'll make it stop. So pretty simple for now. Might need to do some other things in the future. But I guess for simulate as well, I guess you could press the simulate button again to disable simulation. I don't know. Anyway, so what we'll do is icon get renderer ID, which will give us a OpenGL ID, IM texture ID. Cast that into that. Okay, now this next kind of portion. So by the way, if we just launch this now, I don't know how to get this working. Okay, we need to specify a size. So let's make the size, what was the size here? We'll make it in a minute. I just want to show you guys what this looks like. So at the moment, we have a pretty bare bones icon simulator, so to speak, because what we can now do is click on it to change the icon. Pretty cool stuff. So if we take this, now, unfortunately, I can't, doesn't seem like I can dock this anywhere, which is slightly weird, because I definitely should be able to dock it into where I want. That's weird. It's definitely like in the dock space. Not that it should matter. No decoration, no scroll bar. That's weird. Do we already have a toolbar? No, we can't. Why is that not dockable? That's super weird. Let's try and get rid of the flags for now, just to see if that does anything. That's bizarre. Things went differently on the live stream. There we go. Now it's dockable. Like, because you have to use it. You have to use the title bar to dock it. Interesting. But yeah, basically I dock it up here. So that could be, I mean, we can programmatically dock it as well, but that's kind of, it's a bit annoying. But anyway, you can see now we have this amazing thing where I can hit play and pause and it will change the icon. So now actually, this is a bit of a hack, but if we put this back now, it will remain in the same position because the imgui ini file, which is this, actually contains this ## toolbar, right? So we actually have the doc ID and everything here. So we've kind of cheated it because you can see it's there, but I mean, we still have that tab bar thing. The decoration just more or less applies to the window, I guess. So there you go. That's how you fix that, I guess. Bit odd. So now let's do a few things to the styling of this. First of all, why is it, I don't want it to look like a button. I want it to kind of blend in with the interface. Also, when I resize this, I want the button to resize with it, right? So I kind of want the button to, basically the colors to be different. I want it to be in the middle as well. I forgot to mention that. And I want it to resize. So how do I set that up? Well, it's not too difficult. Let's go with probably setting the size dynamically first. So the way we'll do that is we'll switch to using a size variable instead, right? And the size is going to depend on the current window height, and then we're going to subtract 4. Don't ask me why it's 4. It's just 4 because that's like a nice amount of padding, I guess. It just visually looks nice. And you can see now I can resize this and it will resize with me. Now, don't worry too much about it kind of looking like it's touching this. It's because the padding hasn't been done yet. But we kind of notice another problem here. And it's that this is clearly using nearest filtering or point filtering, right? It's snapping to the nearest kind of pixel color value. It's not linear. It's not linearly kind of bilinear, or I should say using bilinear filtering to actually smooth this out and make it nice. And if you actually look at all of our textures, they look like that. And I discovered that during the stream as well, why that was the case. But it looks like for all of our textures, we set the minification filter to linear, but the magnification filter to nearest. I don't know where this code came from or why that's the case, but we should definitely use linear filtering by default. The only reason why you would want nearest filtering is probably for like things like pixel art, or if you're making Minecraft. Well, no, there's a lot of rendering techniques behind the scenes where you might not want to linearly filter your data, but for like actual textures in most games, linear filtering is definitely what you want. Repeat, being on by default is fine as well. That's probably what you would expect, but linear, we definitely don't want nearest filtering by default. Very weird to have it for, well, no, I guess it doesn't matter, but the magnification is the main thing. So if we go back to this now, then that kind of problem should be fixed, and you should see a very blurry play button, because again, it's tiny, it's 32 by 32, but now you can see it's actually filtering, which makes everything else kind of look a lot nicer when you look at it, if it's like slightly bigger. Okay, so that's important, but otherwise, let's continue on with, let's maybe change the actual center position now. So to do that, we can just do IMGUI same line. By the way, guys, let me know what you think about like how we're spending this episode, so to speak, because I would be totally okay with skipping some of this UI stuff and maybe merging it in or copying and pasting it in. But if you are interested in like IMGUI and how to achieve things in IMGUI, and you like this commentary, then I'm happy to do it as well. But yeah. So get window content region max. .x times 0.5. I'll write this out first, then I'll talk about it. Okay, so same line, first of all, means that the next thing should be on the same line. Now, there is nothing before this, so really what we're doing is using same line as a way to actually set an offset, right? Again, I don't know. I'm pretty sure Peter initially wrote this code in Real Hazel, because you can also do set cursor position X. I think that will do the same thing, kind of. Same line will kind of move the cursor back if it's already dropped it down because you have another button. So I guess this makes sense, because if we have multiple buttons, then we probably want to be using same line a few times. For this, it doesn't matter. For the first button, it doesn't matter too much. I guess you can just use set cursor position X. We might check that in a minute because I'm curious. But get window content region max.x. That is how much space we have available. So in our entire panel, our window is currently that big. That's our IMGUI window called toolbar, right? So this is asking it, what is the, how much space do I have for content, right? So mine is padding and stuff. What is this size, right? And then obviously once we get that, it basically is the width, but it includes things like padding. And then we halve it, right? We multiply by 0.5. So that gets us into this point over here, which should be the middle of the window. After that, we take how big the button is going to be, right? Which is that big, remember? And that's both the X and the Y, the width and the height of the button. And we halve that and we subtract it. So what that does is takes the button, halves it, and then offsets it by that much to here. So now the cursor for IMGUI, meaning where the next element will go, is here. And obviously if we take this and we draw the button, then guess what? We get a button that's centered. Now, for anyone who has ever centered something in their lives, you understand this, but I thought I would explain it anyway for people who might be like, magic numbers. So yeah, it's very simple. You can draw it on a whiteboard and it will make sense to literally everyone. It's probably one of the first kind of like layout, I guess, equations that you probably ever learn. Okay, so I guess we should check that out, and I might do my set cursor situation. My set cursor X situation. Okay, so there you go. So you can see that now it looks like it's centered. Again, we have some issues with like the Y and the Y location, but we'll check that out in a minute. Set cursor position X. Just want to see if this does exactly the same thing, because I expect it will. But we'll probably still stick to same line. Same line does more stuff though. You could argue this is better for performance. Yeah, okay, we'll keep it as this, but for other things we might want to do set same line, not set same line, just same line. Okay, so we have the cursor position X, that's looking good. Now what we want to do is yeah, basically talk about the padding. So for this window, I have a few kind of like variations that I want to make to the default IMGUI style. So I can do that by just pushing style variables and also pushing colors as well in a minute. So the first one is window padding. So I don't want any padding in my window. Style var window padding. So, oh, sorry, I do want some. I don't want any horizontal, but I do want 2 pixels of vertical padding. This is just going to make it a little bit like, so the button isn't touching the bottom like that. Then we also have item inner spacing. This is, I think, the spacing like extra spacing that's between items or something. We're just basically clearing that. We don't want any of that. We want items to be a little bit closer together. We're also going to get rid of that kind of outline that they have. Like the buttons kind of look like they're glowing a bit, even though they should be transparent. We'll get rid of that as well. And that's actually the next thing we're doing. So style color. I'm GUI style color. Maybe it's not style. What is it? Just push. No, it is push style color. It's just I'm GUI color. So button. So the button color, what we're going to actually do is set this to be a vec40000. So what this is going to do is, most importantly, change that to 0. So that's just going to make it transparent in the areas that are transparent. That's important. Sorry, button. There's also button hovered and button active. So active when it's clicked, hovered is when your mouse is over it. So same kind of situation, but this should really be like probably not hard coded, because at the moment I've set them to like these values, but yeah, like I think you might want to, well, I think you might want to actually set them to something else. Like for example, this, I think the reason I set it to that is because if we look at the IMGUI layer, then we have our own style, don't we? Yeah, so you can see the button hovered is actually that, and then this is that. So I think what we'll do is we'll actually, here's what we'll do. We'll be a bit better about this than I wrote in the live stream. See, this is what I mean, like improving on stuff is good as well. So basically this is fine. The only thing we want to change is the alpha value, right? So we're going to get, basically, we're going to make an IMVec for, well, no, we don't have to do that. Let's just do, so colors, and then what was this button hovered, right? X. This is a bit annoying though, because it's so big. Might do that. In an attempt to shorten this. X, Y, Z, but then the W we set to that. And then there's also button active. Make this const. And then this is button active, and then that, we're gonna basically do the same thing. It's just gonna be button active instead. So the point again of these is to just lower the opacity to 0.5. That's what we're doing. We're just modifying that part. Now, finally, at the end of all of this, we want to pop everything. So if we do IMGUI pop, so pushes it onto the stack, pops it. So pop style var, and then we can actually put in a count. So we have 2 style vars and 3 colors, right? So push style color, sorry, pop style color 3. 1, 2, 3 colors, 2 vars. Okay, looks good. Let's preview that, and that should hopefully give us a much nicer looking button. Okay, so you can see that I'm not sure, was it supposed to kind of show up like that? I don't remember what it looked like, but I guess that's all right. The point is, you can see we can just until we hover it, I guess that's fine. Until we hover it, we just, yeah, we're kind of we see through it into the background, and it looks like it's the same color as the background. So that's the effect of putting a 0 kind of opacity over here. Well, a 0 value for the alpha channel. Okay, so that looks like pretty much everything that we could want. I think there's one last final thing, and that is with this image button, there's actually a parameter called frame padding, and we want to set that to 0 because it's not currently 0. So to do that, we need to get through these 2 UV parameters. So we'll say IMVec2 0 0, IMVec2 1 1, and then finally 0. So we've changed the frame padding from a default value of -1 to being 0 instead. So let's take a look at that. Okay, and you can see now it actually looks like it's properly centered, right? So that was important. So congratulations if you made it this far. Maybe I'll start chaptering these videos so you can skip certain sections that you may not be interested in. I don't know, guys. Correct me if I'm wrong, but I feel like no one was interested in anything. They'll just like give me the code. You know, I'll just copy and paste this beautiful style you've made. But a lot goes into I am GUI stuff. So yeah, believe me, I know. Okay, so now let's actually make the button do something. So how do we demonstrate doing something at the moment? We don't really have a simulation, like a physics simulation to do. Well, there's actually like already something that we were using the runtime, so to speak, for. And that is if we load something like the pink cube scene, we have a camera in the scene, right? And when we hit play, I want to be able to look at the scene from the point of view of the camera. Now that's very easy to do because all we realistically need to do is just run a different function than we are at the moment. We're running onUpdate editor, which again takes in an editor camera and draws sprites from the point of view of the camera. I want to instead do the function above, which is onUpdate runtime, which again finds a camera in the scene and then uses that. So to do that, by the way, the whole layout of this, I was discussing this during the live stream, the whole layout of this is a bit weird. Like we need to probably create something called a scene renderer so that we can actually render scenes through there instead of from the editor layer and then binding some frame buffers that the editor layer owns. It's a bit weird. Usually you'd have like the way that the proper Hazel works is it has a scene renderer, right? And you can create as many of them as you want for different viewports and stuff. You give it a scene as like the context, and its result is I'll give you a texture. I'll give you a texture with the scene, right? Like based on whatever settings, whatever like modes you enable. So you might not want post-processing. You might not want bloom. You might not want, I don't know, certain other things. It will give you, based on your parameters, a texture. And then you can take that texture and actually you can tell the scene renderer, render directly to the swap chain if it's something that is running in the runtime, like without the editor, standalone, like a game. Or if you don't do that, then it will instead give you a texture, which you can ask it for later. And that texture is what you can pass into IMGUI. So we'll talk a little bit more about that design and how to integrate it here, because that's important. That's probably something I should put into the renderer thing. I'm not logged in for some reason here, but that's something that we'll definitely put into renderer, and we'll talk about like making a proper scene renderer. But for the time being, what we need to do is this section here, but there's also some other stuff that we don't want. So for example, editor camera update, camera control. I don't even know what we're using camera controller for, because I'm pretty sure editor camera does all of this stuff, right? So, and this is like camera control is an orthographic camera control. Like what are we actually doing here? This was, I think, for the game kind of thing, right? When we had an orthograph, when we had like a top-down game or something. I don't know, it's weird. But the point being that what we'll do is over here, when it's time to update the scene, because this actually does, since it does rendering on update editor, right, we'll call end scene, which actually will call flush, which will do draw indexed, which will actually, you know, do an OpenGL draw call. That's contextual. That needs this frame buffer bound, and it needs to be cleared first, right? So we can't do it up here. We have to do it here. So because of that, if we just do switch on the current scene state, right, then if it's edit, I'll actually open up some curly brackets here because we might have a considerable amount of code here that I want to have a proper scope. And then I'll indent that in because I prefer that. We're going to do on update editor, right, inside here. Otherwise, we'll do on update runtime, and that doesn't need an editor camera. Now, this stuff also will happen here, right? So again, I don't think we need this, but we'll worry about removing it some other time. That, I believe, is actually surprisingly all we maybe need. Now, this isn't like a proper runtime. I mean, we would want to, every time we hit play, like in Real Hazel, we copy the scene into a new scene that is our actively running scene. That way, obviously, when we hit stop, we have a scene to restore. It's actually still retained in memory, so we don't even have to worry about loading it. But when you hit play, it makes a copy of the scene that you can play around with. That way, you can obviously simulate the physics, move stuff around, and you can reset to that editor scene version. So let's see if this works. So if I hit play, awesome, look at that. So when I hit play, I can have this editor camera wherever I hit play. It moves me back to wherever that runtime kind of, well, not the runtime camera, but wherever the camera entity with the component is at. And then when I hit stop, obviously I'm returned back to here. So that's pretty cool. I can take the camera and move it. Let's just move it really like far away. And I hit play, and you can see now it's way further. Now this gizmo still appears here. We should probably fix that, but that's basically, that's going to be it. If someone wants to fix the gizmo, submit a pull request. We should probably have like a maintenance episode where I fix all these little things, because otherwise like these videos are going to be very long. But yeah, so there we go. We now have a way to play our scenes. Let's take a look at this scene. Beautiful. And this 3D example, there we go. So these are in 3D space. One's further away than the other, even though they're the same size. So there you go. That is basically the runtime working. So what will happen is once we do in fact have Box 2D, that play will actually start simulating the physics as well, which is pretty cool. And then when we have C# scripting, which is after that, that will also run the on create functions for all the entities, and then the on update functions every frame. So this is kind of important, and obviously, as you can see, it's the basis for a lot. But anyway, I hope you guys enjoyed this video. If you did, please don't forget to hit the like button. Don't forget the source code is on the content browser branch. A little bit weird. Should probably merge that back in. I don't think we're quite done with the content browser. I think that if we try and drag like a texture into the viewport instead of a scene, it will crash. There's a few things to fix there, but we might do like a bit of a stability pass at some point. I might even do that during the week, or maybe, I'm not sure, we'll see, because I do want to get like one major episode of actual work done every single week. Don't forget to follow twitch.tv/thecherno to know when I'm next live. There's a schedule there as well with all of the work that's going to happen for the next episode. Patreon.com/thecherno, best way to help support this series, as well as get access to Hazel. And other than that, I hope you guys enjoyed this new kind of chapter that we've begun with Hazel 2D. I'll see you next week. Goodbye.